All right, welcome to Next Gen Manufacturing. Today we are going to dive into something that's, well, it's pretty much the heart and soul of any modern CNC machine, but it doesn't always get the spotlight. I'm talking about the spindle. It's the real powerhouse, and getting a handle on it, that's your ticket to some serious next-level efficiency.
So think about this. When you need to shave some time off a cycle or just make a process better, what's the first thing you reach for? For most of us, right, it's tooling. We're on the hunt for that brand new fancy end mill or that perfect insert. But what if I told you that's only looking at half the picture? That's right, the spindle itself can be the make or break factor between a sluggish, inefficient job and one that's just flying, pushing parts out the door. It is the true unsung hero of the CNC machine, and today we're going to give it the attention it absolutely deserves.
Okay, so before we can even start talking about picking the right spindle, we've got to be completely clear on what it is we're actually dealing with. Let's break down the heart of the machine.
You know, at its core, a spindle is a really simple but incredibly powerful assembly. You've got the motor, which is obviously giving you the power. You have the shaft holding it all together, and then you have the taper, and that's the critical connection point where you actually hold the tool. These three things work in perfect harmony to spin that cutting tool with unbelievable precision and speed.
But of course, the way that tool hooks up to the spindle isn't a one-size-fits-all deal. That connection is all about the taper, and the type you're using, it has a massive impact on your performance.
The easiest way to think about the taper is like a handshake between your tool holder and your spindle. It's this precision ground cone that has to fit absolutely perfectly to transfer all that power smoothly and, more importantly, accurately. The actual design of that handshake is what really separates the different types of holders out there.
Okay, and this is where it gets really interesting, because the designs are fundamentally different. You've got your CAT and BT holders over here. I mean, these are the workhorses, right? The US standard, using that V-flange and a pull stud to get a good grip in the spindle. They're just fantastic for your day-to-day general purpose work. But then you've got HSK, hollow shank taper. It's a whole different ballgame. No pull stud, the way it engages with the spindle gives you this incredible repeatability and stiffness. That's why it's the champ for high-efficiency milling, or any job where, every single micron is critical.
All right, so our tool is connected. Now we need the juice. But here's the thing. Not all power is the same. And this brings us to that classic battle in machining. The raw, twisting grunt of torque versus the high revving speed of horsepower.
And this analogy just nails it. Think of torque as a tractor. It's not going to win any races, but man, it has immense power to pull and push right through heavy resistance. That's the force that's behind the cut. Horsepower, that's your race car. It is all about speed, all about how much work you can get done in a certain amount of time. It can go unbelievably fast, but it just doesn't have that same heavy-duty pushing power.
So the whole game is knowing when to use which one. You need that tractor-like torque when you're wrestling with big tools. I'm talking end mills bigger than half an inch. Or when you're just hogging out really tough materials like Inconel. On the flip side, you want that race car horsepower when you're working with smaller tools, zipping through softer materials like aluminum, or when the goal is that beautiful, mirror-like surface finish that only high RPMs can give you.
Okay, so we get the parts, we get how they connect, and we get the physics behind the power. Now let's put it all together. Let's figure out how to match the perfect spindle to your specific job. Let's look at a choice machinists make all the time. CAT 40 or CAT 50. A CAT 40 is the most common spindle in the US for a good reason. It's super versatile, it's perfect for tools half an inch or smaller. But let's say you're trying to run a 1-inch end mill in something like titanium. That CAT 40 is going to scream for help. You've got to step up to a CAT 50. Its bigger, higher angle taper is physically designed to deliver way more torque for those really demanding cuts.
So look, at the end of the day, it really just boils down to this super simple 3-step process. First things first, look at your tool. You using something big or small? Simple enough. Second, check your material. Are you cutting something tough as nails like Inconel or something soft like aluminum? And then third, you just match the spindle to those first two answers. Do you need the raw muscle of a CAT 50 for torque, or do you need the speed and all-around utility of a CAT 40? Seriously, just asking these questions up front is going to save you so many headaches. It'll directly impact your cycle times, make your tools last longer, and give you better parts. It's a no-brainer.
And this, right here, is the absolute key. This is the main takeaway. You can have the best, most expensive cutting tool on the planet, but if your spindle can't deliver the right kind of power to it, you are never, ever going to see its full potential.
The tool and the spindle have to be working together. They have to be in sync. So, the next time you're quoting a job or setting up a machine, just take a second to look past the cutter in your hand. Look at the heart of your machine. Is your spindle holding you back, creating a bottleneck in your whole process? Or, with what you know now, can you turn it into your real competitive advantage?